Okay, now that we've spent a little bit of time talking about what delegates are, it's time to see them in action. So Logan's got a very simple console application lined up for this video to demonstrate a delegate in use. So Logan, why don't we spend just a minute and talk about what it is you're going to put together?
Well, what I'm going to do is I'm going to make a demonstration class that is going to do a very simple operation, but it's also going to have a delegated portion of its action.
Okay.
What I want to do is set up a very generic sounding class. I want to make something that I'm going to call a processor. Its job is to process a string. Now, this process method is going to do only two things. It is going to process an incoming string, and it is going to display the processed result. Now, the key here is that the display functionality is going to be specified through a delegate. This means that the code calling the processor can specify the manner in which the display works. So that means from outside of the processor class, we could have the text displayed on screen. We could have it written to a file instead of being displayed on screen, or we could even have the output buffered and displayed later inside of an XNA game.
Okay, that sounds good.
So to get started, we'll begin with the console portion of this example. So I'm going to start a new project inside of Visual Studio. This project will be a console application, and I'm going to name it Delegates Example. And we'll say OK to our new project. And inside of this project, the very first thing I'm going to work on is the processor class itself. So as we've done many times before inside of the project, I'm going to make a classes folder, even though in this case we're only going to have one. And to this classes folder, I'm going to add a new item, and that will be our new class. And I'm going to call this class processing. So it's actually going to be slightly different than the final name of our class, but since I'm going to include the delegates declaration in this class as well, I like keeping the name generic, so just processing for the overall code file. So we'll hit add, and because we added this as a class, our class at the moment is named processing. So the very first thing that I'm going to do is to change this over to a processor class, the class processor. The next thing I'm going to do is take a look at the namespace. And in order to make this code a little bit more portable, I'm actually going to specify a namespace different than the project's namespace. I want to make this code a little bit more project independent, simply because I also want to run this example as an XNA game. So I'm going to make up a new namespace, which I'm going to call processing. So now that we have the namespace and the class taken care of, the very first thing we want to worry about inside of the processing namespace is to define our actual delegate. So I'm going to make a delegate, void return type, called text display. And text display is going to take in a single string. So that will take care of our delegate, and this delegate will be the manner in which we allow ourselves to specify text displaying functionality. So really it's just something that can handle a string.
Okay.
Now inside of the processor class, the only thing it is going to be responsible for is the process method. One other thing I'm going to do to the class is I'm going to specify it as a static class, since I don't want to have to worry about instantiation and we're only going to use one of them. Now, inside of this processor, we're going to have a public method, which is going to be static, no return, and it will be called process. And a process is going to take in two things, the string to process and the delegate to use for processing. So I'll have a string called s and a text display delegate that I'm going to call display. And then the two things we're going to do are process the string, and that is simply going to be a changing of the string to uppercase. So string dot to upper. So again, this is just...
That's the only job of the process.
Right, really is just kind of a pretend processing action here. The idea is just to have something that is simple, but visible, meaning we'll be able to see the difference if we feed in any string that has lowercase characters.
Right.
We should see an uppercase result knowing that the process took place. Then, of course, the next thing we want to do is we would like our process method to display the new string. But, of course, that's done using the delegate. So we'll look at display and feed off the string that should be displayed by the delegate. I'm going to build very briefly just to make sure that I have no simple syntax errors in this class. Everything has built fine, so now let's turn our attention to the program and let's show some of this in action. inside of the program, the very first thing I do before I worry about program code is I'm going to add a using statement to make sure we include that processing namespace, since we did in fact make it different. So we'll say using processing. All right. Now, before we invoke the method to process a string, I am first going to write the method that will handle the actual delegates code here. That way we'll have that on hand so we can feed it over to process when we call it. So the very first thing I'm going to do is to write a static method that allows us to output a string to the screen. So this will be static void, and then whatever name would be descriptive here, something simple like output to screen. Output to screen will take in a string, and we can specify that as s. So of course the functionality here will be very simple. We'll simply tell the console to write a line, and that line will be the string s. Now that we have a method with a signature matching our text display delegate, we can make a call to the processor. Since we're looking into the processing namespace and the processor is a static class, we can look at its methods. It does indeed have a process method, and here we're looking for a string and a text display delegate. So the string will specify something like hello, where most of the letters are lowercase. And the delegate will be a new instance of text display. We'll make sure that text display is set up with our output to screen method.
So this is where you are instantiating the text display delegate and you are encapsulating the output to screen method within.
Exactly. This is where the actual link takes place, where we have our new delegate manage this method, and this is the key point where we specify how text display should work, or rather linking it to the method which display or controls how text display should work. Exactly. And of course this is a console app, so simply to hold up execution of the script before we exit, I'm going to issue a read line, and then we can see what output there is. So once again I'll build, and if there are no errors, I will run the application. And that results in an uppercased hello.
Very nice.
So everything does in fact seem to be working. But now, to test the ease with which we can change the functionality of displaying, I want to write a second string display method. Only instead of physically displaying it, I've decided that I'd rather have the string written to a file. So we'll pretend that this application is now some kind of service, and that we want it to log all of its operations instead of display them. Now, in order to write to the file, I'm first going to begin by including the namespace system.io. So we'll say using system.io. And now we can write a method that will write a string to a text file. I'll make another static void method. This time I'll call the method output to file. And output to file is again going to take in a string. Now I'm going to set up a stream writer instance to handle the actual writing of the data to the file. So we'll make a stream writer, which I will call writer, and that will be a new instance of stream writer, and we'll specify a file name that we would like to write to. So I'm actually going to write to the file that's located on the C drive in our working folder, CS. Then the file name I'll simply call output.txt.
And you've got that open, so you can pull up that folder real quick just to demonstrate.
Sure, to look at that CS folder.
And you can see here that it is indeed empty.
Here we have the folder, nothing in it yet, so this will make it very clear as to whether or not our file is getting written.
Exactly. Oh, or you could think of it as if we kind of feel like magicians, and it's like, take a look in the hat, there's nothing here, really.
Exactly.
Okay.
So, now that we have an instance of a stream writer, I'm going to turn around and use our writer to write a line of text. Only that line of text is going to be the given string. Once that is written to the file, I'm going to turn around and dispose of the writer to make sure that everything gets flushed out, all the data gets put to the file. So we're going to take our writer and tell it to dispose, and that should flush any data out to the file, and of course close the link to the file itself. So with this now, we have a new method.
Of course, at the moment, we're not in any way using it, so if you were to build and run, we're still just going to see hello being echoed out in the console like such.
Exactly. We've specified another method that could be used in the delegation of the display action, but we have not used it. So if I change our call to processor.process and instead tell it to output to file, and then we run, we see nothing.
But we see the console because we're still holding it up with our read line.
Exactly. I did not remove this read line, but so we're sitting here at this line.
But we know something's happening because we're no longer echoing out what we sent in as a string, which is hello, to the console.
Exactly, and that makes sense up to this point because we never specified for our output to file method to show anything on the screen. But let's check that CS folder now. In the CS folder, we now have a new output text file. Inside of this output text file, we have the text capitalized hello.
Very nice.
So that has indeed worked very well. So we can now, with no changes to the processing class whatsoever, change or specify new code, new actions to have happen as processed text is displayed.
Now, before we move on, Logan, and get into demonstrating processing in a game, utilizing our processing little setup right here, let's spend just a second and kind of back up. I'm going to grab the mouse for me for just a second and review. So the big thing to just keep in mind here, because once again, there's probably going to be a lot of people out there that are in the XNA class that came into it new to programming and probably followed along with most everything we did without any trouble up until now. And delegates may come across as being a bit confusing or a bit difficult to wrap your head around until you get into more involved and complex applications where you really need them. But let's just keep things super simple. The key things to remember right here is what have we done? We have basically come in here and we have defined our type right there. So we now have a delegate, a type of text display. And then we've turned around over here and we instantiated it right here, because you've got to declare it, you've got to instantiate it, and then you've got to invoke it, basically call upon whatever method has been encapsulated within it. And that's the whole idea of what we're trying to get across right here. And as you can see, Logan is controlling what method is getting encapsulated into the delegate, as you've seen right here. And then by simply calling on process in the processor, then we can send over the text and we can send over whatever method we want. And that's the cool part. We're able to pass a method. So we're passing this method over as if it was just a regular parameter. And then from over here, we then can make use of that by doing whatever kind of action we would like on the string that comes in, and then turning around and, again, invoking the delegate, basically calling upon whatever method we just passed into this guy.
Right, exactly.
Okay. So that's just a quick recap of that. But now Logan's going to take this a step further, and he's going to demonstrate the use of this in an XNA game.
Exactly, just to show the power given by being able to specify how we use our output. What I want to do now is I want to take this processing class, and I want to move this code over into an XNA game so we can show what would happen if we wanted to use our processor in conjunction with XNA, knowing its particular ways in which drawing has to work. Because over in XNA, we draw things only during the draw method. We can't just arbitrarily output information.
That's right.
So we actually have to take that into consideration as we use the displayed output.
Okay.
Now, in order to move this over to an XNA game, well, I would believe we first need to have some XNA game to work with. So I'm going to switch over to a new Visual Studio, and we can begin our example game. For this project, we're going to go to XNA Game 2.0. We'll make a Windows Game 2.0, and we could call this something like Delegates Example Game. Delegates Example Game. And we'll say OK to that. Now, inside of this game, before we even get into any of the specifics with the processing class, I'm going to do just a little bit of setup to our game class so we get it ready. Basically, I want to be able to display text from within this game, so we'll set up a sprite font in order to handle that.
Okay.
So just a little bit of setup here. We'll begin with a sprite font. So I'll go over to our content subproject, and we can add a new item. And we'll add a new sprite font. I'll name the sprite font Tahoma, so that the Tahoma font is automatically picked up and used. And with that, that's all we need to do. We're not going to change anything, so this is just a default rendition of the Tahoma font as a sprite font. Now, back in the game's code, I would like to specify a sprite font field. So we'll make a new field to type sprite font, which I'm simply going to call font because it's going to be the only one. And while we're in here, we'll make sure we turn around and load it. So down in the load content method, we'll look at our font, and we'll load it from the content manager. So content manager load type will be sprite font, and the asset name will be Tahoma. So that takes care of our sprite font. Now, I do want to spend just a minute and set up some of the basics to the sprite batch drawing. We're not actually going to draw any text yet, but I just want to get the begin and end out of the way. So I have everything in place to be ready to draw. So we'll make our call to spritebatch.begin and spritebatch.end. So of course, in between the two now, once we have desired text, we could render it with a call to spritebatch.drawString. Now I want to take a look at getting our processor class set up inside of this example game. Now before I do that, I want to actually gain access to the code file, meaning if I switch back over to our other Visual Studio where we have the console application, which currently has the processing class, I'm going to begin by saving this console application to make sure we get all this data written to the hard drive. I'll leave the name the same as the project name, that is Delegates Example. We can save that out. So remembering that we should have a classes folder within this project, we can now go to our projects folder. And inside of our projects folder, here is our console version. Here is the game as that automatically is set up to save everything to file upon creation. But if we go to the console version, Delegates Example, and go into the projects folder, we do in fact have a classes folder. Inside of that, we have a processing.cs file, and that contains the class that I want to gain access to. We'll copy this file from Windows Explorer. Then inside of our new game, I'll go ahead and paste it directly into the project. Now we have a copied reference to a file. So what I want to do is set up a folder so we keep the folder structure the same. So I'll make a new, or add a new folder called classes, just like before. Only to this classes folder, I'll simply hit paste. So Control V, and I'll paste in our processing file. So if we look at the directory, though, it is now within the Delegates example game. So it has been copied to our new game example.
Okay.
Now that we have the processing class, we can set it up for use. Now, I could begin a call to processor.process, but we are, of course, going to have to specify a delegate, or method, in order to handle a method to be encapsulated by the delegate. So the very first thing I do before we look at our processor is to simply make a method that can use it. And, of course, just like in the console app, we also need to make sure we're using processing before we actually go in and specify that. So I want to get the method out of the way. So what we'll do is we'll make sure we set up a scenario where we can buffer the incoming text. Because like I said a second ago, inside of XNA, we can't just arbitrarily dump things to the screen. We need to do that only during the draw method. And depending on how the processor works, that could return information at any time. So I want to set up a method that will take any output we've been given, but buffer it into a variable, and then we'll worry about drawing that variable at draw time. So the first thing we'll define here is a string that I can use to buffer information, and we'll call this text buffer. And I'm also going to make sure that this variable, the string variable, is initialized right off the bat, because I don't want to have our draw code possibly hit it before the text was returned, and therefore while text buffer was still null. We want to make sure we have at least an empty string stored in text buffer. And now that we have this buffer variable, I'm going to turn around and make a method that we can use to feed to the delegate when processing. So I'm going to make a private void method that I'm going to call buffer output.
And once again, this here is a particular kind of method that, or not a particular kind, but a method that Logan is writing with the intent of having it encapsulated into the delegate.
Exactly. So we could take a minute just to make sure we remember all the way back to our delegates definition, if we go back to the other project, where we had defined our delegate, and notice the method signature, void return type, and a single string as its single parameter.
So yeah, signature, a string, return type, void, and needs to match.
Exactly. So far we're matching that. We have void return type, and to match everything here, we need to make sure we take in a single string. So we'll take in a string, and we'll name that string S. And for the actual buffer action, all we're going to do is take our text buffer and store the given string in it. So now with that we have a method to use in conjunction with processing, I'm going to move down to the initialize method within the game, and we can make our call to the processor. So we can tell the processor if...
Let's go ahead and do a using real quick.
Yes, I ended up forgetting the using statement. So once again, I had specified the processing namespace inside of that code file. So in order to access that, we'll simply open up using processing. I could have used a fully qualified namespace if I wanted, but just to make this look exactly like the console app usage, we had set up a using there. So we'll make sure that we're using the processing namespace. Then down inside of initialize, we have direct access to the processor class. processor class can be told to process some information. That information will be the string hello, and the text display delegate will be a new instance of text display, which is of course also available inside of that processing namespace. And the method we would like to encapsulate is buffer output. So we'll end off that call. Now we should have, after all of this is run and after the method gets called, we should have some text in text buffer. So knowing that, we can go down to our draw method and draw whatever is in text buffer. It doesn't matter if it hasn't been initialized yet, we'll just draw nothing. A blank string.
That's right.
Or if it has been initialized by the buffer method being called by the processor, we should have some information in it. And we'll use our sprite batch to draw that information. So we'll make a call to draw string. Draw string is going to use the font field for our sprite font. The string will be given by text buffer. We'll position this at a position of 0, 0, so I'll simply feed in vector2 dot 0, and the color we'll use will simply be white. Now with all that, we should be able to build, and giving it just a minute, there are no errors, so we'll run, and we see the text shown as hello, the same processed result, only this time being seen from within an XNA game.
That's right.
And really with that, that takes care of the example. Again, just showing a delegate in action, first in a console app to keep things simple, but also showing that the same class can be used easily inside of an XNA game as long as the given displayed output is taken into consideration and buffered until it can be drawn using the standard draw method in XNA.
That's right. So, I mean, the big thing was at first you defined it, what the delegate's going to be, the signature, the return type, and then you've demonstrated basically encapsulating kind of on the fly different methods. Then we turned around and we brought it over here into our delegate example game and demonstrated it being used over here as well. Just remember the signatures have to match, the return types have to match. And that's pretty much it. I mean, it's pretty straightforward, but again, it's the whole idea of getting your head wrapped around why would you want to do this.
And the cool thing is, and to extend on that point a little bit, another reason for doing this is look at how we had used the processing code file over in our game. For all intents and purposes, we treated this as a closed black box. You'll notice we never even opened that inside of our game. Simply knowing how we had defined the method and knowing how we had defined the delegate meant we didn't have to mess around at all with processing. All of the display-specific code is written ourselves through a delegate.
Right.
So in that way, you could almost treat processing as though it were an external assembly. If this were a library you had brought in as a DLL file, then the same would apply. That DLL file could have a very general implementation for the way its processing worked and allow the end user of that assembly to specify the exact method in which display occurs.
Exactly. All right. Is there anything else you want to add to this, Logan?
Not really. I think with all of that wraps up this example.
Okay. Now, that doesn't mean we're quite yet done with delegates. We're going to move into a slightly more advanced example. So that will wrap this video up. Thanks a lot.